A pleasant morning to everyone, especially to our professor, Dr. Decano. I'm June Albert Apolokyo. I was assigned to share with you the concept of a subgroup under Section 5 based on our reference. In this lesson, we'll be talking about the definition and have some examples in verifying a certain subset or a set is a subgroup or a group. Okay, so as we refer to our reference based on the definition 5.4 stated that if subset H of a group G is closed under the binary operation of G, and if H with the induced operation of G is itself a group, then H is a subgroup of G. We shall let H subgroup of G. So this one is the symbol of subgroup. It's like less than or equal, but we shouldn't be confused using this symbol because we're talking about group and subgroup. You can also write this way. Okay? It's like greater or equal. Wherein denote that H is a subgroup of G and H is a subgroup. Also, we can write this way or this way, less than or greater than. We're in this symbol stating that H should not be equal to G. Alright, so let's try to read closely these important points. So this one, these are the important points. Subset H of a group G, okay, means that H is a subset of G. Alright, next, closed under the binary operation of G means that H and G have used the same binary operation. And this one itself, a group, means that H is also a group. Alright. Let us take a look also. The second sentence state that H is a subgroup of G. As I've said earlier, that this will be the symbol of subgroup, or you can write it down this way. Make sure be mindful with the group or the set. So denote that H is a subgroup of G and H is a subgroup. You can also write this way, but there is a condition that H should not be equal to G if we use this one. Alright. I just wanted to review a certain notation in our previous lesson, subset. If we are talking about subset, we can use this this symbol or the notation of subset, wherein it states that H is a subset of G, or you can write it this way, right? Wherein H should not be equal to G. And here it is, the subgroup, right? The symbol of subgroup. In this case, there is a possibility that H should be, equal to G. And right here, this will be the notations that we're going to use upon proving whether H or a certain group or subset is a subgroup to another group. Alright, moving on to definition 5.5. State that if G is a group, then the subgroup consisting of G itself is the improper subgroup of G. All other subgroups are proper subgroups. The subgroup of identity element is the trivial subgroup of G. And then all other subgroups are non-trivial. right? Based on the definition, these are the terminology stated. First is the improper subgroup. Okay, so means that G is subgroup by itself, and then the proper subgroup, so all other subgroup if it is referred to another subgroup or subgroups. So the trivial consists of identity elements. So right here, this should be the identity element. And then other than that, uh, we have the non-trivial subgroup, means that not just an identity element in a certain group or the group by itself. And now let us proceed to our example. So first things first, we need to remember, okay, the important points as we mentioned earlier, those three important points. First is H is a subset of G. Next will be H and G use the same binary operation. And H should also a group. So for example, it is given that G having an element of integer. Okay, now let's have another example. So these are the important points that we need to be fulfilled in order to verify that H is a subgroup of G. So first is H should be subset of G. Next will be H and G use the same binary operation. And H should be a group. Okay, let's begin. Have this example. We're in G be the group of real numbers under addition. Addition or the binary operation is addition, and H will be rational numbers where non-zero because of this this asterisk right here. Okay, let's put it in a notation. So right here, we're in the element of H, okay, is non-zero, wherein n is not equal to 0. Right, that's it. Right, let us now verify whether H is a subgroup of G. Okay, let's start with the first important point, which H is a subset of G. In fact, a non-empty subset. Well, as we can see right here is this one is non-empty subset. Therefore, we can say that yes, this one is, H is a subset of G. Okay? Because rational numbers are under, rational numbers under real numbers. Okay, so next is H and G use the same binary operation. Well, as we can see that uh, G uses under addition and H is under multiplication. So by this doesn't fit to the next important point. Therefore, it's X by this. Okay. So G uses addition and H is multiplication. Therefore, we can say that H is not a subgroup of G. So that's it. Finally, we'll end this presentation with this last example since our time is limited with 10 to 15 minutes. This example is not notated in a bracket. Okay, for this will be the important points that we should remember and should be checked to verify that H is a subgroup of G. So it is given that G is having a Z sub 4, so it means that having an addition modulo 4 by addition mod 4. So let us make a table out from this given. So this will be the table. So the process of making the table is right here. 0 plus 0 is 0. 0 plus 1 is 1. Or 1 mod 4 is 1. Okay. Right here, 0 plus 3 is 3. Or 3 mod 4 is 3. And right here, 1 plus 3 is 4. Or 4 mod 4 is 0. Just uh, just review the process of modulo. So let's have the H. So in here we have H having a set of 0 and 2. And now let us go with the first important point. As we can see on the given in H, so having 0 and 2, let us analyze whether H is a subset of G. Well, as we can see that since 2 and 0 is a subset of 0, 1, 2, and 3, therefore we can say that H is a subset of G. Okay, this is check. Alright, moving on. So, second important point is H and G use the same binary operation. Well, in this case, as we can see, that both positive and having an addition. Okay, right here. So we're using an addition process, right? Binary operation of addition. So probably it's check both are using binary operation. Well, let's make a table to verify whether they're using same binary operation. So right here, the table of H with this one having a set of 0 and 2. Okay, right here is 0. So, okay. And this is 2. Right here is 0. Okay. Right here is 2. Alright, so we have here 0 plus 0 is 0. Okay, and right here 0 plus 2 is 2. Right, 2 plus 0 is 2. So this will be the table. 2 plus 2 is 4. Well, 4 mod 4 is 0. So in this case, you can say that both are using addition. And last will be H is a group. Well, to verify this one, there, as we can see that addition mod 4, let us see. Let's make a group table. So this is already the table of H, and based on the table we can see also the closure in here. Okay, closure, and we have associativity. Well, you can review the previous lesson on moving group. You can identify or you can verify whether a certain table having a closure or its associativity. But as we can see, uh, we both table having associativity. And also, as we can see that it consists identity element. So right here, having 0 plus 0 is 0 and its own inverse. Okay, and 2 plus 2 is 0 and its identity and also the inverse, hence we can say that H, okay, we can say that H is a group. So therefore we can say that H is a subgroup of G. And right here is the conclusion. So that's it. Alright, that ends my part. Thank you for listening and God bless us all.